So in the last session, we started bisection method. Let me take a quick revision of the formula mainly. So what is the purpose of all these methods that we discussed in the last session? That we have some polynomial, say f of x equal to 0. Now this fx may be a polynomial in x, or it may be a transcendental equation. So transcendental means equation which carries exponential, trigonometric, logarithmic functions. So that other than algebraic term, if other terms present, it is a transcendental equation. So we can find the roots of algebraic as well as a transcendental equation with the help of these numerical method. Now, the first method that we started in the last session is a bisection method. We said this is a bisection. The name itself gives us idea that we are bisecting the interval. What is the iteration formula? Yes, anyone? What is the iteration formula of bisection method that we seen in the last session?
Sir, f of a plus b by 2.
No. It is not f of a.
Sir, a plus b.
A plus b upon 2. First, the first and most important thing, we have to find out the interval AB. This interval AB is generally the two nearest integer, say 1, 2, say 5, 6, like that. So our aim is to get two nearest integer if they are not given in the question. So we have to find out A and B, so that this f of A and f of B should have,
Opposite signs.
Yes, opposite sign. My mistake. So for this fx equal to 0, we find out interval AB where this f of A into f of B should be less than 0. When I say f of A into f of B is less than 0 means obviously either f of A is a negative or f of B is negative. Both cannot be a positive. Both cannot be a positive or both cannot be negative also. Got it? So indirectly f of A and f of B should have opposite sign. If f of A is a positive, f of B should be negative, and if f of A is a negative, f of B should be positive. So this is the very important condition for all the three methods. In mainly first two method, third method doesn't require that, but first two method we should have the endpoints with opposite sign of a function. Now, what this guarantees? Yes, anyone? If this condition satisfies, what this guarantees us?
Function is continuous.
Function is continuous, that is a different thing. You see, a continuous function doesn't have this definition. Yes, fx is continuous and f of A and f of B have opposite sign. What it indicates? There is a definitely,
Root in each of
yes,
them.
very good, correct. A single, at least one root in the interval AB. There is at least one root in the interval AB, because this is the happening there. Graphically, we discussed that also in the last session. So say f of A is here. This is f of A is greater than 0, because so it is in first quadrant. Say f of B is here. This f of B is less than 0. Now you will observe the function have these points, and this is a continuous function. So whenever it the graph starts from f of A to f of B, definitely it cuts the x-axis in at least one point. So this at least one point may be like this. Okay, actually this is not a this is not a function. Sorry. So that about the root there. So I drawn the wrong graph. So say this one. This is say f of A, and this is f of B. And where is the root? The root is here. This is x star. So there is definitely a root there at this point. So that is confirmation. And once we get that confirmation, we use this iteration formula. Say xn is equal to A plus B upon 2. So A plus B upon 2. So it bisects the interval. Simply we get some x1 which is in between, exactly at the center of the interval AB. So when we start the iteration, we say n is equal to 1, n is 1. Then we get the values of A and B there, whatever A and B we selected. Then we calculate this f of A and f of B. So f of A say positive and f of B say negative. So the root is there, and then we get here x1, sorry, xn. So here we can calculate x1 with this formula. X1 is A plus B upon 2. Now say f of x1 is negative. Suppose f of x1 is a negative, then if f of x1 is negative, and f of b is also negative, so x1 should replace b. Okay, so I will say b is replaced by x1. Why b is replaced by x1? Because f of x1 is negative there. If how to get f of x1? You have already function fx. In this fx, you have to replace x by x1 only, and you have to calculate it. So a will be as it is. This is the second iteration, and this is obviously the positive as it is. And then we get x2. What is the formula to get x2? X2 is a plus x1 upon 2 there, and so on. This way to continue now. So say f of x2 is positive now. If f of x2 is a positive, so a should be replaced by x2, because f of a is positive and f of x2 is also positive. So here is x2, and f of x2 is positive, and that f of x1 is negative will continue as it is, and we'll get next iteration as x3 and so on there. We have to continue till the desired accuracy depending on the question that we discussed in the last session. Any doubt in the last method that we completed? Yes, is there any doubt? No?
No, sir.
Okay, good.
No, sir.
Okay. Now come to our second method. Second method is exactly similar to the last method, only we will not take a center point as iteration value, or we are not bisecting the interval to get the next iteration. Instead, see, first condition is the same. We should have two endpoints. Say this is f of x0. Here it is f of x0. F of x0 is greater than 0. You will observe this is x0. So it is indirectly our a. So f of a is a positive. This point is here, which is f of say x1. F of actually x1 is a b here. It is x1 is like b. So f of x1 is a less than 0. You'll observe there are two endpoints whose functional values have the opposite sign. So that about the initial condition. Once this condition satisfies, now to get the first iteration value, we are we are approximating that value by drawing the chord. Okay, we are taking the chord between the point A B. So just join the point A and point B by a straight line, and whatever the intersection is there, this is our first iteration. This is actually the x1 in our standard notation. This is f of a, this is f of b. They have the opposite sign, so we get first iteration x1, and to get x1, the formula is a f of b minus b f of a upon f of b minus f of a. So this is the new formula that you have to remember now. But this formula is taking considering the functional values also. Now we are not only discussing the sign of the function, we require values of the function also. We'll come to that when we do the iteration. So I hope you are getting. So this is our first iteration we got. Now next what we are going to do it, this is our f of x2, or this is in new notation. Say this is a, this is b, this is x1, then this is f of x1. Now we have f of a is a positive, f of x1 is a negative, f of a is a positive, and f of x1 is a negative. Again, the chord is drawn, that is a straight line is drawn between the point that a and x1, and we get a next iteration, say x2, and we have to proceed further. This is f of x2, then f of x2 is a less than 0. You'll observe continued, and we get a new iteration, say x3, and so on there. So this way we always try to go closer to the real root, and again we get an approximate root by a method of false position or regular falsi method. So the name of this method is a regular falsi method, false position method, and the method is based on the chord. Okay, assumption that when we draw a chord between the end points, that chord gives us the iteration value. It is not the bisect value there. Got it? Any doubts?
No, sir.
No sir means
And no doubt.
no doubt.
No
Okay,
doubt.
okay, thank you. I thought you not understood. Okay. Here is the example. Now see the example. Now I already told in the last session, you should have a calculator with you. You should have a calculator with you, and you should do this calculation. In the exam, the answer you can write in this table form also. You can do the solution in the table form, or if you want, you write a descriptive way. Already both ways I given in the that handout. I shared one PDF. Okay, I shared one PDF with you, and you can see that solutions given in table form, this form, also in the descriptive form also. Descriptive form, it takes time only. Okay, you are wasting your time in write description there. Better you write the answer in table form. I generally prefer this way. See the question is find a real root of this cubic equation. Obviously this cubic equation you can solve it on calculator also, and that calculator gives you the root. But right now we have to do it by a numerical method only. So find the real root of this cubic equation by a false position method in the interval 2 comma 3. So in the interval 2 comma 3. So already initial points were given, that interval is given. Interval is a 2 2 3, 2 3 is interval. So the first row, you will observe this first row is just heading like this is n is the number of iteration, a and b is the interval in which we are looking for the root, then f of a and f of b. Now here see, in the previous method we just written negative and positive because we are not worried about the magnitude of f of a and f of b there. We are interested in just sign of the function. So I written there negative and positive, and then f of x1 is negative, like that. But here you have to write entire value there. So now how f of a is a -1, replace x by 2 here. If you replace x by 2, 2 cube is 8, 8 minus 4 minus 5. So 8 minus 9, that is a -1, that way. So you have to do this calculation on calculator and replace these values here. Now here is a formula for x1. The x1 is a f of b. So here is a, here is f of b, a into f of b minus b into f of a divided by f of b minus f of a, and you will get this value 2.0588. Remember, generally you should write each number at least it is better to write up to 4 decimal whenever it is not mentioned. Whenever it is not mentioned, see, I am written each and every calculation up to 4 decimals there. So minimum 4 decimals should be there while doing each and every calculation in numerical method. So here is 2.0588, that is x1. So f of x1 is calculated. So this value of x1, is replaced here, and we get f of x1. F of x1 is minus 0.3908. Now can you tell me which should be replaced, a or b? Next interval, whether we have to
Sir,
replace
A.
a. Yes, correct. A should be replaced because f of a is a negative, f of x1 is also negative. So a should be replaced, and you will observe previous a is a 2, it is replaced to the 2.0588. Okay. The reason we replace a because f of a and f of x1 both are negative. So just negative term is replaced by negative only. And this is a positive remain throughout till end. Okay, throughout this problem. So this may happen throughout this problem. Actually, f of b is always positive, and that f of xi's are negative. All f of xi's are negative. You'll observe this is negative, this is negative, negative, negative. And near about 7 iterations we done. And after 7 iteration, after the 7 iteration, now here in the question you will observe nowhere it is written that do that number of iteration. What is the stopping criteria that we are given? Instead we are given this answer should be correct to the 3 decimal places. So when the answer is correct to the 3 decimal places, anyone? Yes, any idea how you decide that answer is correct up to 3 decimal places? This answer is correct to the real root up to 3 decimal places. So that is we are saying. Any idea?
Sir, F of A.
F of a, there is nothing with f of a there. This is f of a you are saying. Okay. Why this is correct up to 3 decimal places? Because 2 consecutive iteration. You will observe the 2 consecutive iteration. That number of decimals should repeat. So you observe 0 is with matching with 0, 9 with 9, and 4 with 4. So these first 3 decimals start repeating. Start repeating. If you take x8 also, you will observe this 3 decimal will continue there. Once they start repeating, now it will continue. So then we say it is correct up to that 3 decimal places. You will observe here is 2.05 is there, 2.0588. It converted to 2.0813. So 1 decimal, it is correct up to 1 decimal only. This solution is correct up to 1 decimal, up to second iteration. So up to second iteration, we get 1 decimal correct. Then in the third iteration, we get it is correct up to 2 decimal places. You will observe 08 is repeated with a 08. Okay, but it start changing up to this place. So it is a 0.209. Generally, yes, generally one last decimal may change there, but once it start repeating, actually it never changes general. Okay, because if you do the roundup part, actually here 2.089 is there, it is 2.09 will come, that is 2.09 is correct up to 2 decimal there, then 2.09 and that 4 start repeated here. So generally, just simple thing, you can keep it. There will be a small error, I will tell you, even though we are saying it is correct up to 3 decimal places like 2.094. Maybe the correct answer may be 2.095 or 2.093 also. So that very small error, because at the end we are calculating the approximate root. It is not exact root. So it is, but it is more closer to the real root. So that is the thing that is happening here. So whenever decimals start repeating, you can say that is correct up to that decimal places. Got it? Any doubt? Is there any doubt?
No, sir.
Okay.
No, sir, no doubt.
Yes, sir.
Okay, good. So this way you have to complete the table. Okay. This is now one more question I will show you, but that is not because in last session also we just seen the algebraic function, that is a polynomial function. But let me see one of the example on a transcendental equation. Okay, so here is that second example. The question is, find the root of this equation x e raised to x equal to cos x using the regular falsy method, correct up to 3 decimal places. So the meaning of this last line is important. That generally gives a stopping criteria. So here it is written correct up to 3 decimal places, means we have to do the iteration till the first 3 decimals start repeating. Okay, this is one of the way to stop the iteration, or another way in the question itself given, do the 7 stages of the calculation or do the 6 iteration like that. Okay, so that is another way to stop the iteration. So everything is given in the question, you should not worry. Suppose by mistake if it is not given, you can do the 5 iteration, minimum 5 iteration there. Choice is yours then. Okay,
Sir,
yes.
sir, the f of a and f of b in the previous question, the f of a and f of b will be always given.
Not necessary. See the previous this question, is it given? Are they given A and B? Not given, na?
Yes, sir, not given.
Not given. So whenever it is given, you have to find the root between that interval only. If not, then you have to find out two nearest integer where function changes its sign. Okay, we are going to find out two nearest integer which are near to the 0 again. We start with x equal to 0, x equal to 1, x equal to 2, and we'll proceed and we'll find out two nearest integer where the function have the opposite sign. Okay, so this may happen in this question. They are not given, a and b not given, and again fx is not given in like fx equal to 0 form. It is given on both sides. So just take cos x on the left hand side or x e raised to x on the right hand side. Choice is yours. So we can take fx equal to x e raised to x minus cos x, or the vice versa, means this term on the other side there. Okay, only that case your f of a is positive, then someone get f of b as positive there, because they taken which term on which side they are taken, that decides mainly the sign of the function. But at the end your answer will be unique. Okay, don't worry, the answer is definitely the unique there. So we'll start this question. So first thing, yes, the trigonometric term and exponential term appeared. If at least one term appeared, trigonometric or exponential, it is a transcendental equation. So whenever the trigonometric term comes, remember you have to do the calculation on calculator only in a radian mode. Can everyone able to change this mode of a calculator? Is it?
Yes, sir.
So don't forget to do the calculation of transcendental equation, mainly the trigonometric term. So it is only trigonometric term. You have to do it in a radian mode of a calculator. If you do this in the normal mode, your answer completely wrong. Okay, completely wrong. You will get probably the 0 marks also. So don't forget, this is for trigonometric function. finding the roots, use a radian mode. So here is the solution now. Step number one. Okay, let I write what is fx taken. So what we have to do it. We'll start say fx equal to, let fx equal to, so you should start in solution. That's not written, I'm not written here, but that you should start in solution. Let fx equal to x e raised to x minus cos x. Okay, x e raised to x minus cos x. So that is fx we taken. So everything, all the terms we taken on one side of the equation, so that we get fx, the function x, function of x. Now go in the radian mode and just calculate f of 0. Replace x by 0. So f of 0, that is 0 into e raised to 0. This is obviously 0. What is the cos 0?
Sir, 1.
Cos 0 is 1. Okay. Now cos 0 is 1. So in that case, f of a will come a negative, minus 1. But what is the problem here? I may taken. So instead of this, I will just use other ink. So this one is I not taken. That means I taken fx equal to cos x minus x e raised to x. Now you can check all the calculation with this function. Fx is cos x minus x e raised to x. That way also you can do it, but your interval means at the end you get the same answer, which is 0.5176. Okay, whatever that answer, that you'll get exactly same answer. You can try it. You can try it like a homework. Okay, but right now just I will tell you that this is cos 0 is 1 and 0 into e raised to 0. So this f of 0 is 1 there. So that way you got this for this fx. For this fx you got this 1. Okay, so now you replace x by 1. So you get cos 1 minus 1 into e raised to 1. And you should get this value. Can anyone check, cross check this value? Is it correct? So cos 1 you have to do it in radian mode. Don't forget to change the mode of a calculator. So just press the mode continuously and you will get degree, radian and gradient mode. So that time press 2, you are in the radian mode. You will press cos tab first, cos of 1, which you get 0.5030. Okay, 0.5030, that is the value of cos of 1. Then minus 1 into e raised to 1. So how to get e raised to 1 on calculator? So just press shift ln tab, you will get e there, and just press 1, then just press 1, e1. So you will get the answer as minus 2.17799 there. Is it, everyone is getting this value? Whether all of you are getting this value? Hello.
Yes, sir.
Yes,
Yes, sir.
sir.
Okay, good. If you have the remember, use a calculator. Don't forget to practice a calculator, because these things looks so obvious, but in the exam you may stuck how to get e raised to 1, so or how to get e raised to 2. So to get e raised to 2, just press shift ln tab where you get e, and then just press 2. Don't take upper arrow there, no need of arrow. E2, you calculator gives e raised to 2 there. Okay, that way. Now you will observe this f of a. F of a is a positive, f of b is a negative. So we stopped. We stopped that root lies between 0 and 1. So we will not calculate f of 2, f of 3 and so on. Because f of 0, this is a rough work, you can do it. F of 0 you got as a positive, f of 1 you got as negative. So we can say thus the root lies between 0 and 1. So you take x as a, so a as a 0 and b as a 1. And now this x1 is calculated. And you will observe f of x1 comes a positive there.
Sir,
Yes.
so we can, in every case, can we start from A as a 0 and B as a 1?
Every time you can start with a 0 for trial, but suppose f of 0 is positive, f of 1 is also positive, you have to go to the 2 then. Okay, if 2 is negative, then root lies between 1 and 2. Then that time a and b are 1,
Okay,
2.
so then it's a hit and trial method, no? We have
Yes,
to
yes,
try
yes,
and check
yes,
that which
obviously,
one.
obviously, correct, correct. It is hit and trial method. That's the correct uh, name of the method. It is a just use a hit and trial method to decide the interval first. Once you get a two nearest integer where the root exists, then take that two nearest integer as a and b. Got it? So you'll observe f of x1 comes as a positive. F of x1 is positive. So we should replace, now we should replace then a by x1, because so a is replaced by x1 here. So right now I am taken 5 decimal. So minimum 4 decimal should be there. I'm generally says you should have minimum 4 decimal. So 5 6 decimal if you take, you'll get more accurate again. But it's better to write at least 4 decimal. And you'll observe 0.31 is there, which converted 0.44. Here first decimal started repeating. So in third iteration we get 0.4 and 0.4 first decimal. So it is correct up to 1 decimal here. But yet it is not that 0.4 is changed to the 0.5. So here it is repeated now. So this is the final correct up to 1 decimal, then 0.51, then 0.517, and then 0.517. So in 8th iteration, mainly in 8th iteration, it start repeating the first 3 decimal. So after 8 iteration, it is these numbers are not completed. You have to do write these numbers. Remember, there are a few things are missing. This f of x3, f of x4, f of x5, x6, they are not written here. That I done on the page, but I not written. You can fill up these numbers. You can fill up these numbers. The table will be always complete there up to here. Okay, up to here. So this value is not required only. So here it is this 0.517 and 0.517 is repeated. So you can say after 8th iteration, the answer is a 0.517, correct up to 3 decimal places. That's one. Any doubt? Is there any doubt? No doubt?
No, sir.
Okay.
Excuse me, sir.
Yes.
Sir, can the value of xn be negative?
Yes, it can. It can, obviously. Where that chord is there, whatever means how that chord is there. If the chord have say, if a chord is descending, means if a chord is going like I will show you on the graph here. So suppose this is f of a and this is f of b. So you will observe curve may be like this and this chord is like this. Okay. Whenever the chord is decreasing or descending, it have the say negative slope. If negative slope, then f of xn is always negative. This f of xn is always negative. Is that because your chord go like this, and all these are below x-axis generally, and then you have negative. But if this f of a is here and f of b is there, and your graph is like this, if the graph is like this, the chord have the positive slope, and probably in such a case, it may happen. This it depends now. Actually, if okay, this may be the case. This may be the case where depending on this xi value, actually, depending on the xi value, whether this have always positive slope or negative slope, it decides. And yes, but I will tell you that f of xi can be a positive or negative. That's fine. Okay, don't go in the detail. Okay. Okay, so